Okay, gents, let's continue on here now with this one. Question 8, a financial maths question. Mary wants to borrow €15,000 at an annual percentage rate of 5.5%. She wants to repay the loan in 6 equal installments over 6 years, with the first repayment 1 year after she takes out the loan. Each annual repayment will be €1. Write out in terms of the present values of the first 3 payments. So make sure that you pause, have a shot at it first before I go and explain it to you. Okay, so she's going to pay the same amount of money each time. Let's say it's 1,000. Clearly it's not 1,000 because 6 payments of that would be quite the bargain if you were borrowing 15,000. But let's just say it's 1,000. It's asking what is the present value of €1,000 when the first repayment happens. So that's in a year's time. So how much is €1,000 worth? €1,000 that will be in a year's time be worth now? And the point here is that you don't need to have €1,000 now in order to have €1,000 in a year's time. You can have a little bit less. So let's say it's 990. I don't know what it is. Let's say it's 990. Why? Because it grows by 5.5%. Okay, so you need something that will grow into €1,000. So we've got a little formula that we use. Future value equals present value times 1 plus I to the power of t. And if we're looking for present value, and we are, that's the future value divided by 1 plus I to the power of t. So that's what the present value is. So in my example of if it was what's €1,000 worth right now, €1,000 in a year's time, what's that worth at the moment? You would just say 1.055, and that's what you would do to find out what the present value of €1,000 that you would be receiving in a year's time, how much is it worth right now? So we will just have that little thing on standby because it's useful. 1 plus I power of t, and it's p. Remember, p is your present value. Okay, so in this case, what are we doing? It's A is the amount of money that we will be paying. So it's A divided by 1.055, and it's the power of t. Of course, t is 1 year, so it just stays there. The second repayment, 1.055 squared. Third repayment, 1.055 cubed. So what that's saying is, if we take our 1,000 as the example, what it's saying is if I need 1,000 in 3 years, it's even less that we would need, because whatever amount that we need is going to get multiplied by 1.055, and then by that again, and then by that again, in order to reach 1,000. Okay, 1,000 isn't what we're dealing with. A is what we're dealing with, so we call it that. Write out in terms of A the sum of all the present values. So this was our first payment, remember, 1.055. This was our next payment, third payment, and so on. I suppose they've asked us to do all of it, so we will. Remember, it was 6, writing what I'm saying. It was 6 monthly installments. Yet again. The point I was trying to think ahead to is, am I going to finish on 6? Am I going to finish on 5? Am I going to finish on 7? Well, there should be 6 things here. It starts with to the power of 1. Okay, it starts with the power of 1, and if there are 6, it should go 1 to 6. That's a handy way just to figure it out. Okay. Write out in terms of the sum P of the present values of her repayments as a geometric series. There it is. Okay. Use the geometric series. So we have Sn, because it's a sum, and it's A times 1 minus or to the n over 1 minus or. It's worth pointing out what's A and what's or. A is the first term of the sequence. So A in this case is that number there. And or is what you multiply by to go from the first to the second, from the second to the third, etc. And I think you can see a stays the same, so we're multiplying by 1 on the top, and we're multiplying by 1.055 on the bottom. So we have that a is equal to a over 1.055, capital A over 1.055, and we have or is equal to 1 over 1.055. Okay, and we have to do this to calculate it. Well, when we add them together, this is the present value. This is what all of these payments are worth right now, and what they should be worth right now is what we're borrowing, 15,000, because we're getting that right now. So all of these things, that their present value should be 15,000. So we'll fill in our 15,000. A is capital A over 1.055. It's 1 minus or, which is 1 over 1.055 to the power of n. N is very important here. It is the number of terms, and it's not good enough just to look at the 6 and go, oh yeah, the 6 terms. You have to say, yeah, it was 1 to 6. It was 1 to 6, there are 6 terms. But for instance, it could be that it starts with capital A plus, and that would go to the power of 5. That would be, for instance, if you had a case where you weren't paying at the end of the year, you were starting paying immediately. It would look like this. N in this case would still be 6. You're still adding 6 things together, even though there are only 5 of them. Even though, sorry, it ends in a 5. There are, in fact, 6 of them in that instance. But in this case, it's straightforward, but that is something that I definitely want you to look out for. So that is the power of 6. And it's over 1 minus 1 over 1.055. Okay. Right, there's a lot of things just to throw into our calculator, really. 1 minus 1 over 1.055 is certainly not a nice number. So we get 15,000 is equal to A over 1.055 times, well, I've typed in the bottom, it's 11 over 211. This thing here we'll type in. You can just manipulate. Of course, you can use your A and S thing. That's what I often tell you to do. It's just a faster way to do it. It's this thing to the power of 6. That doesn't come out as a particularly nice number, 0.27475467. Okay, best thing to do, I think we should take that number divided by this thing. So let's do that. So divided by 11 over 211. So we have 15,000 is equal to A over 1.055. Divided by that thing, that's 5.270284476. That's going to be divided again by 1.055. So we get 15000, and look, this number is almost exactly 5. 4.995530309. I'll keep it exactly accurate. So it's 15,000 divided by that thing, ANS. To me, comes out as €3,002.68. Okay. That is what A would be in that case. So let's just see, does that sort of make sense? Well, if we did 6 payments of that, we'd be paying back 18,000. So certainly if you were paying back anything less than 15,000, you would think that that is very strange and wrong. So you should be paying back a bit more than that. So 18,000 seems like it's not a mad number to get. Okay. The loan amount P is the sum of the present values of all of the repayments assuming the payment is made at the end of the month, is made at the end of each payment period. If A is the periodic payment amount, T is the number of payment periods, and I is the interest rate, write out P as a sum in terms of that. Okay, well, we're going to do the exact same as what we did before. Now remember, F is equal to P over 1 plus I to the power of T. This is actually on a sheet that I already gave you. But you know what, it's really good practice to do it. That is the present value of a particular payment, okay? And the payment we were using was A, and it's what we will continue to use. Okay, so that very first payment, let me see, what were they actually asking? Write out P as a sum of T terms. So we'll say the first one is 1 plus I, and it's to the power of 1. The next one is A over 1 plus I squared, A over 1 plus I power of 3, so on and so forth, all the way up to that final payment, which will happen in T years. Okay, hence show that this thing is true. So we're just going to use the same formula again. Sn is equal to A times 1 minus or to the n over 1 minus or. So in this case, again, we're going to have to say what's A. A is, A is capital A over 1 plus I, and or is equal to 1 over 1 plus I. And in this case, n, how many things do we have? Well, we started with, to the power of 1, 2, 3, finishing at T. We've got T things. Okay, we've got T things. Okay, let's do it. Sn, the sum of these things here, is equal to, it's equal to A, which is A over 1 plus I, times 1 minus or, which is 1 over 1, 1 plus I power of T, over 1 minus or, which is 1 over 1 plus I. Okay, so that is a particularly awful looking thing. Okay, now remember, when we are adding these things together, when we do add the sum of it, okay, it should equal to the amount that we have gone and borrowed. So the amount that we have gone and borrowed is P. So we can just replace this thing here with P. Now we're trying to get A equals, so let's try and do that as painlessly as possible. Multiply both sides by this number that I'm writing down now. It's equal to A over 1 plus I, and here we have 1 minus 1 over 1 plus I. That's the power of T. Okay, remember we're looking for A equals and to go from there. I think strikes me off the top of my head that a good thing to do here might be to say P 1 minus 1 over 1 plus I. That thing times 1 plus I is equal to A times 1 minus 1 over 1 plus I, the power of T. Okay, and now we have that A is equal to P times 1 minus 1 over 1 plus I times 1 plus I. Actually, you know what? We can multiply that in. Okay, we can multiply that in. We can do that by 1 and that by this. Okay, so that by 1 is just going to be 1 plus I. It's just itself. And when you take this thing and multiply by that thing, you get 1 plus I over 1 plus I. So we're just going to get minus 1 there. Okay, that's really handy. So that's what you get when you multiply that thing in. And what are we going to be doing? What were we doing? We're dividing by both sides by this number here. So we just got a on that side, and on this side we have 1 minus 1 over 1 plus I, the power of t. Okay, so on the top we have p times I, and on the bottom here we can write it as 1 over 1 minus 1 over 1 plus I, 1 plus I to the power of t, like that. Okay, and it's equal to a. Now let's just look at it versus the thing that we want it to be. Okay, so the thing that we want it to be is pretty close, but we aren't quite there yet. Okay, so maybe I'll write it up here. So we have the pi, and we have 1 over 1 minus 1 over 1 plus I to the power of t, and it's equal to a. So it's just a little bit easier now because I can see the whole thing on the screen as to where we are meant to be, where we are meant to be going. Okay. As you can see, we've got our p and our I, that's fine. The rest of it we don't particularly have here, so we're going to have to do some adjustments. So we'll call it pi, and this thing here, well, from the law of indices, to the power of n is a to the n, b to the n. So if you've got 1 over 1 plus I to the power of t, it's 1 to the power of t, and of course 1 to the power of anything. You know, 1 multiplied by itself doesn't matter how many times, it's just going to be 1. And here we get 1 plus I to the power of t on the bottom. Okay, so actually it's just 1 over that. So when I place this in here, I'm going to write it as 1 over 1 plus I to the power of t, like that, and it's equal to a. Well, we're dealing with a fraction, okay, and with a fraction you can multiply top and bottom by whatever you want. And the thing that it strikes me to multiply top and bottom by is 1 plus I to the power of t. Because when you multiply the top bit by it, you just get 1 plus I to the power of t. When you multiply, there's still a pi here. When you multiply the bottom of it by 1 plus I to the power of t, well, first of all multiplies 1, so it just stays as itself, 1 plus I to the power of t. And then when you multiply by this, it's that thing over itself, so you just get minus 1. And look at that, hey presto, we've got the thing that we want. So we'll say it's p, we'll multiply it, this is I over 1 if you want to think like that. So we just say I by the top thing, so that is 1 plus I to the power of t. And on the bottom we have 1 plus I to the power of t minus 1. And that is equal to a. And that is exactly what they wanted us to get. They can ask that. It's typically not worth a ton of marks, but it's something that you should be able to do. You want to press home your advantage here, and that is a good one to do. Okay, use this formula to show that you get the same answer for that previous part. Okay, well that is just going to be a calculator bash. So it's going to be P is 15,000 is what we're putting in. I'm going to be relatively smart about this and actually just say that I was 0.055, press equals, and then do P. So it was 15,000 multiplied by, get our brackets, its answer times 1 plus the answer. That is going to be to the power of 6. And it is 1 plus the answer to the power of 6 minus 1. And hey presto, it's 3,002.68. I wouldn't write it just that. I would show my examiner what I did. I did 15,000, just so you know. I did 0.55. No, 0.055 multiplied by 1.055 to the power of 6. That was that bit over 1.055 to the power of 6 minus 1 is equal to A, where A is the payment that we're making monthly. So I did 15,000 by that. Okay, and that got me the answer. Mary decides she wants to make monthly repayments. Were there any options? Oh yeah, sorry, we were dealing with annual. What is the equivalent annual rate of paying per month? Okay, so what I've done is I've just got you to do, as you know, monthly the 12th root of 1.055 and subtract 1 from it. That will get you what it is. But you know what? I just want to show you as well, just in case they ask you to derive this. I know this came up on the mock exam that you had, and they actually really wanted you to derive it. So I'll just show you how we're getting this thing here. So its future value is equal to present value times 1 plus I, to the power of t. So if you think about it, if we have an annual rate of 5.5%, what that means is if you have at the moment €1, in the future, in 1 year, you will have 1.055 right there. Okay, so that is what we want to get. But when we are finding the interest rate here, okay, the interest rate is now going to be monthly, and therefore how many times it's going to have to compound in order to turn into 1.055? Well, it takes a year for that to happen, and since we are dealing monthly, it is to the power of 12 is what t now is. Okay, so you have 1.055 is equal to 1 plus I to the power of 12. 1 times it is just itself, and now you get the 12th root of both sides. Okay, and there you have it. I is equal to the 12th root of 1.055 less 1. Now I just kind of got you just to just do that quickly because it's a fast way to do it. But if they are looking for something more substantial, if they are looking for you to derive it, make sure that that is what you're doing. Okay, we'll do the 12th root of 1.055 minus 1. Of course, when you put in minus 1, it's a real pain as to what it comes out as. So maybe just add 1 to it, and then you can just write it down, except without the 1. 1.04471699. Okay, use the formula in B part 2. So that was this one here, to find out how much she would be paying back every month. Okay, so let's do that. So I'll put it in minus 1. Okay, so I have my I in here. P is still 15,000. That was our loan amount multiplied by, we get our fraction A and S, which is our monthly thing, times 1 plus A and S. Now it's to a power. Remember, this is over 6 years still. Use the formula to calculate if she pays back. Okay, she's paying monthly. We're still assuming that it is 6 years. So if it's 6 years, okay, if we are dealing with if we're dealing with 6 years, you just need to be careful not to type in 6 anymore, because it's monthly. It's going to be 72 monthly payments. So it's 1 plus A and S to the power of 72, and it's 1 plus A and S to the power of 72 again, and minus 1. Okay, the amount that she would be paying back is 244.13 is the nearest amount there. That's what you should pay. Again, don't just write it out. Do actually fill in the formula, show your examiner that you know what you're getting. Now, before we even go on, I could guess what they are going to be saying here, and that is, what's the difference between paying monthly and paying annually? And the difference is this. If you're paying annually, that very first payment happens in a month's time. and the 15,000 that you owe is growing that whole year. Whereas when you pay monthly, after a month you'll have paid off a little bit of the 15,000. So that little bit won't be growing during the year like it would have been if you were paying annually. So it is better to pay back monthly because not as much of the thing is growing as you go along. So if we take that amount there and multiply it by 72, you'll see that actually it's not a gigantic saving, but every little helps. 17,577 is what you get, 0.29. Okay, when you multiply that monthly amount by 72, I forget what it was. It was like, we'll take our 3,002.68 and multiply it also by 72. That's 21,692.96. No, it's not. What am I talking about? No, it's 216,000. Of course it is. And that's because we wouldn't multiply it by 72. We should instead be multiplying by 6. So, sorry. So that was 18,000, which I think we already said. And 16 euro and 8 cent. So it's obviously the difference between those two, 577.29. So she's saving herself a saving of 438 euro and 79 cent saving. Okay, this was our 3,002 and a bit times 6. That's how we get this one. This one is our monthly multiplied by 72. So that's why that's happening. And it's also important that you understand why it's happening. They could ask a question that, you know, where you really have to think about the whole thing as you go along. Okay, I will stop here and we'll move on to the next one just afterwards.